All right, continuing our topic on weather. In this series, or in this presentation, we're going to talk about air masses. Changing weather. An air mass is a large body of air that has about the same conditions throughout it, same temperature, same type of humidity. Air masses take on the conditions of the area where they form. So if they form over warm tropical waters, they tend to be more humid and warmer. If they form over cold, dry land, they tend to be drier and cooler, and other combinations too. Number 3, winds and air currents cause air masses to move. Those causes changes in the weather. The jet stream is a high altitude stream of fast moving wind that blows from west to east and affects us here in North America. The prevailing westerlies here in North America also move those air masses around. A lot of air mass motion is caused by the sun heating our atmosphere, which results in temperature changes. And as we've discussed before, those temperature changes aren't the same in every location. A front forms at the boundary between two air masses, where those two air masses meet, or sometimes multiple air masses. Types of fronts include cold, warm, occluded, and stationary fronts. Clouds, precipitation, and storms commonly happen along fronts. A cyclone is actually a system of winds that rotates around a center of low air pressure. An anticyclone is a system of winds that rotates around a high center, or a center of high air pressure. Air masses and fronts. Warm and cold air masses do not mix easily. Warm air masses are forced to rise and expand over cold air masses. Cold air masses wedge themselves underneath the warm air masses. The warm air that gets wedged or forced up eventually cools. Moisture then starts to form, condenses, and that forms clouds, and then rain or snow may form if the warm air continues to rise. Cold fronts, where a cold air mass moves onto a warm air mass. Big thunderstorms in the summer and snowfalls in the winter are weather conditions that we expect with cold fronts. A warm front, where a warm air mass moves onto a cold air mass. Steady, long-lasting rains in the summer and steady snowfalls in the winter are what we can expect with warm fronts. Stationary fronts, where a cold air mass and warm air mass meet and neither is moved by the other. Conditions can last for days sometimes. That front, those two air masses, they're just kind of hanging out, producing only alto cumulus clouds. Temperatures remain steady. Winds are gentle to maybe not even any at all. Occluded fronts, where warm, cool, and cold air masses come together. Weather conditions associated with an occluded front can be divided into 3 categories. Kind of before they passed, while they were passing, and after they were passing. So again, that's an occluded front is where we kind of get a combination of all these different things coming together, and therefore kind of has a mix of weather conditions. Oceans and the climate. The temperature of the ocean affects the different climates on Earth because water in the oceans holds a large amount of heat. The sun is the main source of the Earth's energy in our atmosphere. Both oceans and land absorb solar energy. We talked about before how they don't absorb it at the same speed. Oceans absorb more energy from the sun than the land. They do make up about 3/4 of our planet, or cover about 3/4 of our planet, so it absorbs and soaks up a lot of energy. The ocean stores and then moves a lot of that heat energy, and then that is going to in turn have an effect on weather and on climate for different areas. All right, and here's a diagram that they call the ocean temperature conveyor belt, and kind of color to help represent these ocean currents. There are dozens of different ocean currents, but this is kind of one of the main ones that they're showing here. And here is the United States, the eastern part of the United States. It shows a warm current kind of coming up along our north coast and then flowing north and then curling back around. And then as it curls back around, it's actually starting to cool down, pulling that cooler waters. And as it travels from one place to another, it carries those temperatures with it. And that is it for our presentation on air masses.